Welcome to civil engineering exam. Today we are going to see how to evaluate the liquefaction potential of soil in the field. So the evaluation of liquefaction potential of soil in seismic prone region is very important and very essential for site selection, planning and construction of the structures. So we can access the liquefaction potential through the standard blasting test and ground response analysis, then laboratory test and expertise. So the use of laboratory test is not desirable due to the difficulties in taking the undisturbed samples in the field and reconsolidation process. So that is very difficult to get the undisturbed samples. That's why the laboratory test is not a very good method to calculate the or evaluate the liquefaction potential. The standard blasting test is the main technique to access the liquefaction potential. A specific quantity of explosive material is placed at a certain depth based on the explosive geometry, spacing and the soil type. After the explosion, the settlement is determined to find out whether the soil layer is susceptible to liquefaction during the earthquake or not. So for instance, a particular project, a sand layer with a thickness of 7.5 to 10.5 meter compacted with 5 kg ammonite explosive was detonated under the ground depth of 4.5 meter. It was observed that the resultant settlement ranged from 8 to 10 cm within the diameter of 5 meter, the explosive point being the center point. So the ratio of the settlement from the successive shots were 0.6. Hence, there was no need to take the liquefaction into account. So this is the main method, that is the standard blast techniques. So next one is use of ground response analysis and laboratory test procedure. So this procedure includes a ground response analysis to specify the stresses generated in the soil layer during the earthquake, then compare the determined stresses with those noticed to cause failure in the cyclic load test in the lab. So this technique provides a mean for considering the effect of amplitude and time history of the earthquake ground motions, the in situ properties of soil, variation of overburden pressure with depth, and the position of water table. The procedure of ground response analysis followed in the laboratory. So first step is evaluate the magnitude of ground motion they may develop in the base rock at the site under consideration, and second step, specify the response of the overlying soil to the base motion. Assume the deformation of the soil is mainly due to the vertical progression of the shear waves as a result of the base motion. And third step, idealize the shear stress history at the various depths to find out the significant number of stress cycles and the equivalent uniform cyclic stress developed in each layer. So after that, we can determine the cyclic stress required to cause the liquefaction of the sand in the significant number of stress cycles. The cyclic stress can be found using the cyclic test is representative sample of the sand from the site. So finally, we can compare the magnitude of equivalent cycling stresses developed at the any depth with the cyclic stress, then cause the liquefaction for the condition existing at the depth to specify whether liquefaction would occur or not. So this is the another method we can find out the liquefaction potential in field. So this is most important when the earthquake is happened. The liquefaction is the most important thing to cause the failure of the buildings. So that's why we are very much cautious about the liquefaction. So again, we will see in next video. Thank you.